All right, students, this is for the Big Bang Theory, Hubble's Law Gizmo. So when you open up the CAMI assignment, please take a look at these prior knowledge questions. These can be answered without doing anything on the gizmo, just common sense. So if headlights are equally bright, which motorcycle is closer? Give me an explanation for an answer. Okay, on the warm-up here, 1912, an astronomer named Henrietta Swan Leavitt studied a class of stars called Cepheid variables. These stars change from brightness to dim to bright again. Her discoveries led to a method of measuring distances to other galaxies and eventually helped support the Big Bang theory of the origin of the universe. So once you log on up here, click the Explore Learning and log on to your Gizmo using your username and password that you've already set up. You're going to go to your class and you are going to launch the Hubble Law Big Bang Theory, Big Bang Theory's Hubble Law Gizmo. So we're just going to go to the warm-up. You're going to select region A. Look at the image of the Andromeda Galaxy, which is relatively close to our Milky Way, and locate the two Cepheid variables, the stars that change brightness over time. Star A091 is the L star, and A171. So when you click on region A, those stars are located. Here's one right there, and here's the second one down there. So you're going to locate those. When you click on them, it doesn't tell you which ones they are yet. You'll see in a moment how you determine which ones are which. So which star is the greater apparent brightness? Apparent brightness is the one that looks brighter. So in your viewing, your observation of these two, which one looks brighter? You might need to look at them and because you notice they're pulsing. Which one looks brighter? And answer these questions, which takes longer to pulse. And because both stars are in the same galaxy, they're about the same distance from Earth. Based on what you see, how is the brightness of the star related to how quickly it pulses? So just give me an explanation. So we're going to get the gizmo ready. We are in region A already, the Andromeda Galaxy. If not, click that and select region A. And we're going to start collecting data here. So locate the stars, the yellow Cepheid variable, A-091 in the lower left section, and click the Collect Data button, and you will see a graph of the star's brightness and how it changes over time. So we're going to select this one. We're going to hit Collect Data. And what we're seeing is here you have the time in days. Here is the brightness of the star, and you can see it's pulsing. It gets brighter and dimmer, brighter and dimmer. So you can answer that question, how does it change over time? Turn on Show Time Probes. Select the left probe to the first brightness peak and the right probe at the second brightness peak. So we're going to turn on Show Time Probes. We're going to slide this over till it's at the top of that peak. I'm going to slide this one over till it's at the top of this peak approximately. Okay, notice that's at 1 day. That's at 13.2 days. So that's what we're going to record. 1, put a 1 here. 1.0 days and 13.2. What's the time difference? Subtract these two. 13.2 minus 1 would be approximately 12.2 days. This is the period of the Cepheid, right? That's the period. So in the Data tab, record the name of the star and do the same on your data worksheet. You do not have to do it over here. You don't have to record it over here because we're going to be using this over several days. But you do have to record the name of the star, which is A-091. and the period, which would be 12.2 days. So do that on this bottom worksheet here, right here. So you can use your text tool. And A-91 period 12.2 days. Word days in there because it's already listed. Okay. And then we can move on to the next direction. Collect data. The apparent brightness of the star is shown on the y-axis of the graph. The brightness is given a ratio on the star's brightness to the sun's brightness if viewed from the standard distance, 1 megaparsec, which is about 3.26 million light years. For example, a brightness of 4,000 means that the star appears 4,000 times as bright as our sun would appear if it were the same distance. So what is your estimate for this star A091? So what would an estimate brightness be? You see it peaks here above 9,000 and it dips down here. That's well below 6,000. So that might be like around 3,000 and 9,000. That it's bright, real bright, about over 9,000, and down here about 3,000. So what do you think it's going to be? You would put that estimate here. Turn on show mean brightness. Click on show mean brightness. Up, and there is your answer. 7,004. So that means it's 7,004 times brighter than the sun. So you would type in your 7004. Record that data on the worksheet. So we're going to record that again on the mean brightness right here, 7,004. Okay, now we're going to observe the spectrum. We're going to click record spectrum. Stars emit wavelengths of light. We used this last week in the spectrograph gizmo. So you're going to use the shape tool to insert the line. So you're going to look at A091. So record spectrum. And you can see these dark lines here. You're just going to put those lines on the picture. So we're going to use the shape tool, and I'm just going to do insert line. I'm going to pick, I don't care what color, and I'm going to put my lines kind of in where the lines are. There's kind of one green blue, there's a couple over here in the purple and blue area. So something like this here. They don't have to be exact as long as you get them close. One between the green and yellow. Something like right there. Okay, and you just put the lines in there. Now you're going to record and click done and select the other Cepheid variable in the Andromeda galaxy and determine and record the period, mean brightness, and spectrum of the star. So we're going to click done. Click this other one. Click collect data. Show time probes. Put it at the peak. Put it at the other peak. So that would be 0.3 and 4.4. Subtract those and we would get 4.1. So our period would be here would be 4.1. Our mean brightness, click on mean brightness, is 2499. We would put 2499 right here. Okay. And you would do that with determine the record the period, the mean brightness, and spectrum of the star. So if you look at the spectrum, click record spectrum. You can look at that there. You don't need to record that anywhere. I don't think it has to, you can't record it anywhere. So don't worry about recording that. Just do the um, the period and the mean brightness. Okay, and then you are going to click Done and click Return to Map. Click Region B, and you'll notice a star here pulsing. Okay, so you're going to need to collect the data for that star. Show time probes. Move it on the first period, right around 0.2 days or so, and then move it to the second one, 3.3. The difference would be 3.1. Show mean brightness, 92.66. Record that in the data table down here. Keep recording, and you're going to do that for all of the regions and all of the stars. Pay attention. Sometimes there's more than one star in the picture. So return to map, region D. There's a star here. You'll see them. They're probably pulsing. If you can catch them a little bit earlier. Return to map, region E. Got one here. That's nothing. Return to map, region F. There's one. You're going to collect the data for period and mean brightness on that data table on the last page of your CAMI assignment. After you're done that, then you can finish answering the compare questions here, and then you can stop. If you have any questions, send me a message through Schoology, through email. If you have trouble with the assignment, log on to the office hours between 11 and 11:30, or 1:30 to 2, or contact me if you can't make those hours, and we can arrange a time to get together to go over this. All right, I hope this video helps. Good luck with completing the assignment.